Hello everyone, my name is Praneeth P.K from Srinivas Institute of Technology, Department of Artificial Intelligence and Machine Learning. Today the topic is about the Wumpus World, which comes under the artificial intelligence. The Wumpus World or the Hunt of Wumpus is a computerized game built or starting from 1972. It's still an what we say a professional game in AI. So, the Wumpus World environment. So, the Wumpus World is a cave. The agent explores a cave consisting of rooms connected by passageways. You can see the cave here. Luring somewhere in the cave is the Wumpus. Wumpus is a monster, okay? A beast that eats any agent that enters its room. Some rooms contain bottomless pits that trap any agent that wanders into the room. Occasionally, there is a heap of gold in a room. The goal of this is to collect and exit from the world without eaten by the Wumpus. Okay? Typical Wumpus world. As I said, the agent always starts in the field of 1, 1. The task of agent is to find the gold and return to the field and climb out of the cave. The Wumpus world. Let's see the performance measure. So the performance measure includes the agent get 1000 points if he grabs the gold. If he died by falling into the pit or eaten by the monster, he will lose 1000 points and -1 per step. If our agent travels one step of the grid, he will lose 1 points per steps. -10 for using the arrow. Okay, the arrow is used to kill the Wumpus. Environmental square adjacent to Wumpus are smelly. The square adjacent to Wumps are smelly. Square adjacent to the bit are freezing. The square adjacent to the pit are breezy. Okay, if gold is in the same square, means it will glitter if the gold is in the same square. Shooting kills Wumpus if you are facing it. Shooting uses up the only one arrow, means the agent get only one arrow to shoot the Wumpus. Grabbing picks up gold in the same square. Releasing drop the gold in same square. Okay. Actuators. We have actuators and sensors using the Wumpus world. Actuators like left turn, right turn, forward, grab, release, shoot. Sensors breeze, glitter, smell. Means sensors like we have a breeze here and breeze here also. Also we have the stench smell, and also the glitter we can see here. Glitter if gold is there, breeze indicates the pit, and stretch indicates the monster. So as I said, our 4 into 4 grid rooms, the agent always starts in the square labeled of 1, 1 facing to the right. Okay. The location of the gold and Wumpus are chosen randomly. The Wumpus or the gold, its decision of picking is randomly, but not in the first, because the first position is only for the agents. So the Wumpus or gold can anywhere is in the 4 into 4 grid except this. In addition, each square other than the start can be a pit also with probability of 0.2. Let's see the actuators used. One is the move forward. The agent can move forward, turn left, turn right of 90° only. Grab. The action grab is used to pick the gold or grab the gold. Shoot. Shoot is used to kill the Wumpus, and climb is used to climb out of the cave after collecting the gold. Sensors. Sensors, as usually said, sensors which make sense the agents. The first is the stench. Stench is the smell of the monster, presence of the monster in the adjacent room. Breeze signifies the proximity of a pit, warning of potential danger. As I said, if you feel the breeze, if the agent feel the breeze, it indicates that there will be a proximity of pit in its adjacent room. Glitter reveals the location of the goal, the agent's ultimate object. So the goal will be finding the goal. Bump indicates that the agent has attempted to move into a wall, providing information about the cave's layout. Okay, let's see the agent's first step. So here we have our agent at 1, 1. Now the agent decide to go to 2, 1 and he felt it's okay, but at 2, 1 we have breeze. So the agent felt that this or this, it contains a pit. So in next he decided to go again to the first position, like here see, he felt the breeze at 2, 1, so he decided to come here. So he decided to come here and he went right after 1, 2, and he felt, and here he felt the stench smell of the monster. Let's see the later stages of agents. After the third move, the agent felt the smell of the Wumpus, so now he knows that 1, 3 contains a Wumpus or 1, 2 is an Wumpus. But as for his knowledge, while he visited to the 2, 1, he felt the breeze, but now he can only move towards 2, 2. So he decided to 2, 2, where he visit it and felt it okay. There he felt the glitter of the gold here. So the agent moved towards here and he felt, and he grabbed the gold over here, and he came back as route as he went on the same direction. So here the agent sensed with the stench smell and with the empty room, and then he felt all together as stench, breeze, glitter and none. In this, for this Wumpus world, there are 3 types of search algorithms are used, mainly depth first search, breadth first search and A-step. Explores one branch of the search tree to its end before backtracking. Like explore one branch of the search tree to its end before backtracking. In breadth first search, explore all nodes at a given level before moving to the next level. In A-star search, a heuristic search algorithm that uses estimated cost to guide its search at the chip cost. Decision making strategies used in this: the agent's success relies on its ability to make informed decisions based on its current knowledge and the information it receives. As you saw in that, based on the information here, the agent didn't know like what's in 2, 2, but he knew that in 2, 1 he felt breeze. So this is the information he kept before making the decision. Okay, first is perceptual information. The agent analyzes its sensor readings to gain insights into the cave's layout and potential threats. Search algorithm execution. The agent uses a search algorithm to explore the cave, searching for the gold while avoiding the hazards. Knowledge base upsets. The agent incorporates new information into its knowledge base, updating its understanding of the Wumpus. Action selection. Based on its knowledge and the result of its search, the agent chooses the best action to take. So, knowledge representation. The agent must store and manipulate knowledge about the cave using the information to make informed decision. First, for this knowledge base, a collection of facts and rules that the agent uses to reason about the world. The agent have some knowledge base over this Wumpus world. Then he decided to roam about this world. Logical inference, the process of deriving new knowledge from existing information. Reasoning, the agent's ability to use its knowledge base to make decisions and solve problems. Like how the agent decided by its knowledge representation to move towards the Wumpus world and grab the gold. And next we come across Wumpus world using propositional. Okay, as in the previous topic we have learned about the Wumpus world and how a knowledge based agent involves in the world. Now in this topic we will create a knowledge base for the Wumpus world and will derive some proofs for the Wumpus world using propositional. Okay, Wumpus world using propositional. Okay, the same, the agent from the you will start from the first square of 1 comma 1, and we know that this is a safe and open to the agent to build through base for the Wumpus world. We will have some rule and atomic proposition. We need a symbol of I comma j to symbolize this Wumpus world, where I indicates the row location and j indicates the column. Okay, let's see. Atomic proposition variable for Wumpus world. Okay, let Pij be true if there is a pit in the room Ij. If P Ij be true if there is a pit in the room. Let Bij be true if agent pursue breeze. If agent pursue breeze. Let Wij be true if there is Wumpus. Okay. Let Sij be true if the agent pursues stench. If the agent pursues stench. Let Vij be true if square Ij is visited. Okay. Let Gij be true if there is a gold. Let Okij be true if the room is safe. So Wumpus world, some propositional rules for this. See, for the yes 1 comma 1, there is no Wumpus in this, and in 1 2 there is no Wumpus here, and in 2 comma 1 there is no Wumpus, and in S21 there is no Wumpus here, and there is no Wumpus here also, and there is no Wumpus here and nor here. And for R3 which is 2 comma 1, there is no Wumpus here, nor here, nor here and here there is an Wumpus. And for 1 2 at the 1 comma 3 we have the Wumpus, and we found out the Wumpus here, and 1 comma 2 and 2 comma 2 and 1 1. This is the propositional rules for the Wumpus world. There is an improvement for the Wumpus. It's asked that prove that Wumpus is in the room 1 comma 3. In the room 1 comma 3. We can prove that Wumpus is in the room 1 comma 3 using propositional rules, which we have derived for the Wumpus world and using inference rule. We will use modus ponens with negation S11 and R1. We will first apply MP rule with R1, which is negation S11 with negation W11, negation not with 1 2 and negation 2 1 in negation S11, which will give the output as this. For this as per the logic, we have Wumpus 1 1, not Wumpus 1 2 and 2 1 with the yes negation S11. So we'll get the same as it is by using modus ponens and applying an elimination rule. After applying an elimination rule for negation W11 and W12 and W21, we will get three statements which is shown here. Apply modus ponens to negation S21 and R2. Now we will apply modus ponens for negation 21. We have done with S12, now we will go with S21. And we have the statement over here which will give the output as shown here, the same sequence for S21. Apply an elimination rule, the third step. Now again apply an elimination rule to negation W21, W22, W31. Will get statements of W21, W22 and 31. Apply MP to S12 and R4. Apply modus ponens as we previously did, which is this output. No, that input for this output will get the same as it is. Now at the unit resolution on W3 or W12 or W22 and negation 22, okay, we have this input, and for the W22 we will get as W13 VM12 12 because W get cancels. So the remaining we have written here. So this is an so for the next we have unit resolution on W13 W12 with 1 2. Here the W12 and W12 will get cancelled, so the remaining is W13, and that proves that the Wumpus was in 1,3. Conclusion and takeaways. The Wumpus world is a fascinating example of how AI agents can reason, learn and make decisions in complex environments. The first was we learned that knowledge representation, the importance of representing knowledge and reasoning about the world. And the second one is search algorithm, how the search algorithm helped the agent to backtrack or solve problem and find solution. Decision making, the ability of AI agent to make informed decision based on available information. Thank you. And next, the first order information will be continued on the next session. Thank you.